His domain expertise involve Kubernetes, Hadoop, Spark, and all the tools that are essentials for this workshop. Let's listen to him in that case. And Rajat is currently working as a part of open source project development for Indic languages, collaborating with the AkeStep. So he's also part of India government mission on developing resources and technologies for Indic languages, especially related to the data and AI models. So with that, like, I'll leave the forum to Rajat. Please take over, Rajat.
Thank you, sir. Thank you. I think that was quite extensive introduction. And just to correct, like we have started just 1 year back on
Oh,
this.
I'm
And yeah,
glad. Okay. I
so
thought like it was 2 years. I mean, the amount of work that has gone, I mean, it was
yeah,
2 years, 2 years. Like, yeah.
yeah. And we have other team members apart from Anirudh and Harveen. So we have more volunteers from ThoughtWorks itself who have contributed a lot in the journey, like over this 1 year. So we have Sorgio Sen, we have Hira Ballab, and we
Uh-huh.
have Ishab Gaur as well.
Okay.
So
Sorry,
they
Rajat. I'm not aware of them. Please,
no
if you can
issues.
introduce them. Yeah,
Yeah,
that will
yeah.
be
So no
helpful.
issue. Basically, they will be helping us in this workshop because the number of participants is around 90. So they
Right.
will be helping us out in sorting out the issues if any group faces, right?
Sure, sure. Thanks to them. We'll get introduced to them
Yeah,
over the flight. Yeah.
sure. Okay, so I'm sharing my screen and we start quite quickly now. Uh, so basically, I think for building good models, we need good data, right? The good data means the amount and volume of the data should be enough, and the quality of the data should be good. So how do we do that? And the scale, you think that it's quite humongous. Like we trained the model with 10,000 plus hours of data of multiple languages. So it's not a simple thing to do if you do in a very closed environment where you just work on a VM or basically do the things just for experimental purpose. It's more about operationalizing the whole model building and building a platform so that people can quickly generate the data sets and start and do the model training on that humongous data sets. So it involves a few processes at very high level I'm talking about. So first process goes with the data collection, which is itself is a very challenging task. So how do we get the data? From where we get the data? What are my sources? Should I get the data from YouTube or should I get the data from any other website where not lot many audios are there? How do we find that, and how do I collect the data and bring it to our infrastructure in a structured way and in a way that I can process it further for our model training? So that is very crucial step. So we'll talk about that in brief. Then we have data cleaning and processing. Again, this is audio, right? And audio, there are a lot of challenges in audio. It's not a structured data. It's basically a kind of data which has a lot of attributes which are not visible directly to the human eyes, right? We will discuss about those attributes, but it's not a text data or data which is human readable. So it is challenging to clean that data. It is very challenging to process that data, and the size of the data itself is huge. So we need sophisticated, or you can say, scalable architecture to process all these audio that we want to use in our training. Then the third step comes the pre-training step, which is the unsupervised learning, which runs typically on a very large data set, around 10,000 hours of data set, which is not labeled, which means it's just audio data, and we feed that data to the model, and model do the clustering on the phone names and all, and we get the good cluster of multiple phonemes that are there represented in multiple languages. So Anil and Harveer will take this session afterwards. So today we will cover first two steps basically, and the fourth step is the fine tuning, which is kind of making the model learn more and giving that it's kind of a supervised learning where we fine tune the model on a particular language, or it can be a language, it can be a language with a specific domain as well. So that's how we fine tune the model and get the and make it better by giving the labeled data set. So the requirement of the labeled data set for fine tuning is very less. So that's why this model strategy is working well for us, that we don't need too much of labeled data basically to train the models. Earlier, the algorithms we were using, which were deep speech 2, it required all of the data that needs to be labeled only. So that's a game changer for us, and that's the reason that we have seen good amount of success so far as well. So we'll discuss about that in later days. Today we'll this focus more on data collection and data cleaning and the infra setup for that. Okay. So data collection and processing, as I said, data is huge. Like the data is availability of data is not the problem, but the problem is how do I find the data which is useful to us, right? How do I systematically download the data and put it in my infrastructure? Uh, Volume is high, right? As I said already. So yeah, I mean that we'll discuss in later parts. So this is how we have this defined this workshop, at least for these 2 days, 22nd, 23rd. So initially we will discuss about the theoretical part of it, which is not represented here. Then we'll do the infra setup from ground up. We'll start from zero and do the infrastructure setup. And then we will do the data acquisition, which we will download the data from multiple sources and see and basically run it from our machine basically and see how it works. And data processing we will do for today, and this is it. That is it today. So because it's very initial setup will take some time, so that's why first day is little leaner in terms of covering all the aspects. But tomorrow we'll cover further things, like we'll do the data analysis, like how many genders are there, like who spoke what, how many speakers are there in my whole data set. So all these things we'll discuss tomorrow. And the test transcription, which is for generating the labeled data set for our fine tuning model, that as well we'll cover tomorrow. Data validation, which is more around a sanity on the data set that we create. So we want to be double sure that whatever we have generated is good for our model training. So we also run some validation jobs on top of that data just to be sure of what we are feeding to the model is good, because this model training is very expensive. It involves GPU and it very runs for multiple days. It's very resource hungry and costly as well. So we don't want to waste that effort basically by feeding bad data to it. Then we will discuss about how can, once we generate, how can we publish the data to ULCA. So ULCA is basically a platform that is being built right now as a part of the government initiative, which is kind of an open API, and it is it is called Unified Language Contribution API, where once the data sets are getting generated, we will publish them to the ULC as a contribution. So that is what we do, and that would become a huge corpus for the whole India ultimately. So that is the goal. And then we'll see how we can use this model data set for the model training, which Anirudhan has been covered. Okay, any questions so far? I think I have been. Hello. Can you hear me, sir? Deepak, sir? Hello.
Yeah, I think we can continue.
All right, sure.
There are no questions, I think.
Please stop me and please ask questions in between, because I thought that I lost everybody and I was just speaking. So
no, we are listening to you carefully.
Sure. Okay. Cool. So data acquisition, basically, so I'll just open the documentation. I think whatever we want to do, we have kept it as a part of our documentation itself, which is quite extensive and covers everything that is required to do this data processing and all. So I'll refer to that documentation, because that is the kind of a one stop for everything for us. So that's why I've not kept it in our slides. I think we can continue here. So I think this is, I think we have already covered Scrapy in our last sessions, right? Prerequisite sessions. So we are using Scrapy as a framework to download the data sets from multiple sources. So we have written the spiders for YouTube. We've written spiders for the web URLs. We have written spiders for Google search, Bing search. So 95% of the time we use the YouTube spider. And basically then we have the pipelines which downloads the data and basically keeps that in our GCP bucket. So we are using GCP bucket as our storage for keeping all our audio content. And yeah, so that actually framework downloads the audio as well as the CSV file which has the metadata of that file, basically of that audio. So yeah, this is a very high level view of the like architecture of this. Basically it can run on locally or it can run on a cloud platform, which is Zeit. So the reason we are using Zeit is basically it is kind of a platform where it is designed for scraping. So you can see the challenges if you run from the local machine or VM. The IPs can get blocked quite easily because many websites or web services have the rule that they will block the IPs if it is a scraper or something. So we use a well-defined or predefined infrastructure which is meant specifically for scraping. So I'll just open that quickly and show you that. So this is the Zeit we have. I think we'll cover that more in the hands-on session. So I'm just giving you some pointers that this is the platform where we run all our scraping code.
Rajat, if I'm correct, Zaiti is a wrapper or a layer on top of the Scrappy, which helps us to go through those IP
Correct.
blockages if in case you have, right?
So you can say basically it's kind of a infra for running the scraping code.
Okay, okay. And also, Rajat, do you think like YouTube is the largest repository of data if in case we want to grab the speech data, or do you think like there are other good resources as well?
So for us, YouTube works very well. I mean, we have scraped a lot of data from YouTube. Apart from that, I think we recently found one government source which is which we are using, and we have scraped around 15,000 hours of data from there. So there
It's
can be
all
more.
India radio thing, right? Yeah.
Yeah.
Broadcast data. Yeah.
Correct.
Yeah.
But
So there can
YouTube
be
data is
more.
not clean, right?
YouTube
Sorry.
data is not clean. Correct. It's not clean.
So how you are cleaning their data?
Yes. We'll cover that definitely. Yeah. That's a good question. So yeah, that is basically our. I think scrapey architecture and all. I don't need to cover again. What do you want me to open that and discuss and talk about the scrapey architecture?
Yeah, it's better. Like if you can just briefly talk about that architecture.
Sure. So I think you might have seen
Also,
this
Rajat,
architecture.
if you can just increase the web page size, it will be legible. Yeah, thank you.
Yeah. So this is the architecture of Scrapy. So it is a framework that has multiple components. So as you can see, the one component is the spider, which actually where you define the part where we define what needs to be scraped, what should be the content that I need to scrape and create the request and response object out of it. Then we have a downloader basically, which is used for downloading the data from the internet. And the item pipeline is what we use for what needs to be done once you get the data from the internet, right? So I'll quickly show you the code as well if you want. I mean, so in the data acquisition framework, so this is our repository. Git remote -b if I do. This is our repository. I think you might have already seen this repository. I'll send you the link for this repository. Just give me a moment. Yeah. So this is the repository. I'll just send it as a in the chat as well. Okay, so please look into this and please provide. There's a star, like you can, if you like this repository, once you see that, please provide the star as well. Okay. Yeah. So I was showing the code. So in the code, you will see we have package. We have some folders like spiders, right? So this spider is basically we define what we need to collect, what need to be parsed from the internet. So parse method basically is the one where we define what needs to be scraped, and ultimately it actually yields an item basically, which is nothing but a key value pair of kind of attributes that we scrape from the internet. So here you can see it is basically calling this YouTube util, which is going to the YouTube and finding out the channels based on the configurations we have done. I'm not diving deep because that's a theoretical session, but giving you an idea that by parsing we are providing and yielding item, basically YouTube item, which has the channel name and ID and the file name. And then once it is yielded from here, that goes to the pipeline basically. So in the pipeline, so when we run this code, we provide the pipeline that need to run when you run this crawler, this spider, right? So I'm running, let's say I'm running this data collector YouTube spider, which is this one. What needs to be done after this item is received, right? So that is defined in this YouTube API pipeline. So this YouTube API pipeline is here in the pipeline folder. So here basically it gets the data in the process item method, that item basically, which we yielded from here, right? So this item we yielded from here, and this item is received here basically. And on this item, then we do the downloading part basically. So we first check whether it is already downloaded or not, all the state that we are maintaining the bucket itself. And the checking if it is already downloaded, then we don't download
Actually,
the
it is.
right.
Excuse me. Actually, it is not visible. Can you increase the font size so
Oh yeah,
that?
yeah, sure. So let me just see that. Can you see that now or not? Okay.
Yeah, now somewhat visible. Yeah.
Okay, let me try more actually.
Zoom in.
Yeah.
Yeah, now it's visible. Yes.
Okay, sure. Cool. So yeah, basically I was just giving you a very brief idea about the code, how the code is structured. We'll definitely touch upon this in more detail. So just wanted to show corresponding to a diagram I was showing that these are the spider, these are the pipelines. Okay, I think we can move on, right? We can move on to the next part. Yeah. So so the next part, once you get the data downloaded, right? Now the question is that data is not useful, right, at all. That is just a raw data, and it can have a bad data as well, and we need to do a lot of cleaning and processing on the data to make it eligible for the model training, right? So that was the question someone asked. So we basically do a lot of things. So we convert all the types of file format to the wave format, which is required for model training. We downsample to the sampling rate of 16,000, which we'll discuss slightly later on. We'll break the utterances into smaller utterances using voice activity detection. Model requires 1 or 2 seconds to 15 seconds duration of the audio only. So that's where we utilize this utility to break our large audio into smaller utterances. Then we calculate the duration. We also calculate the signal to noise ratio, which is a kind of a quality of the audio, because for model training, it requires more human speech rather than noise or basically unwanted signals which are not a part of the human speech. So that for that we actually calculate that sound to noise ratio, which typically is from 1 to 100, and the higher it is, better the quality of the audio is. And we also build the catalog. So catalog is nothing but a kind of a metadata for the audios that we scrape and download, and we keep that in a database so that we can query and understand our data, right?
Rajat, Sai Ganesh had some doubt. I think he has raised his hand.
Sorry.
Hello, sir. Yeah, I have a query regarding how would you consider the overlap speeches? Would you drop it? There will be overlap regions, right? When you crawl it from some sources.
You mean deduplication? Yes.
No, sir. Like in an audio sample, I assume there are two speakers, right? There might be some overlap. Do you consider that overlap region, or you discard that one in the database while collecting? Do you have any? Yeah.
So when we collect data set, basically we do a lot of processing afterwards to identify the speakers in the data set.
Okay, so you mean to have there is some diarization algorithm such that it will identify from what point to what point speaker one is there and
correct. That's what we do. I mean, that is the part that we'll cover tomorrow. It's already there in our.
Okay, sir. And other query, sir, like when you're crawling the data from YouTube, right? There will be some copyright issues, right? So how would you tackle them? Because I'm in one of the contributors for this crowdsource project. So we are facing some issues with the YouTube data.
Right. So when we crawl, we have a setting that tells you that you have to crawl only the Creative Commons data. So Creative Commons data doesn't have any copyright issues. So we basically download the Creative Commons data.
Okay.
Yeah. Or the government data. Yeah.
Thank you.
Hello.
All right. So
Hello.
Yeah.
I have one basic question. Like in calculating SNR, we don't have any reference. Like how you are measuring that SNR, because we have whatever raw data we are collecting. So we don't have any reference to measure the SNR. What is in range it is like.
Basically it actually, I mean, that's a good question. So that utility that we are using, that gives you stats ranging from 1 to 100, right? Then what we do, we filter them based on the threshold that we have kept in our mind that works well for us. So when we do the model training, we reject everything which is below 20, right? So we in the SNR, we don't filter out anything. We just calculate the SNR, right? And then once you get that stats, we filter out everything which is below 20, the utility is giving, because that worked well in the past for us. So that is how that's our benchmark basically for SNR.
So for calculation, we need a reference. That is my question.
That I understand. Basically for calculation, the utility that we are using, that is doing that, and it's little black box for us. I mean, Anirudh can intervene here and can tell this.
So we are using WADA SNR. It basically models the clean speech as a gamma distribution and then models noise as a Gaussian distribution. So we experimented a lot and we found some parameters which work for us. So we saw that for most of the clean samples, anything which is above 15 to 20 range, that is not very noisy, and that is we take as clean speech. And anything below 15, that ratio, that is something which is very noisy, and we ideally reject it. Sorry.
Thank you, Andrew. I got it.
And sir, how we are annotating our data, downloaded data? Like YouTube does not have a transcript. For training model, we need transcript also.
So we'll discuss that everything in detail. Basically, from YouTube, we just download the audio data, and then we use them for our pre-training. And then, if required, we also generate the transcripts. So that transcription part we will cover tomorrow. Basically, how we will generate the transcript. So we don't use the YouTube annotated data. That's what I wanted to clear. We don't really use the data, the labels that are attached to the audio in the YouTube. We don't use it.
Okay, sir.
Rajat, in case we want to access YouTube annotated data, right? Is there a way for us?
We can extend this pipeline. I mean,
Okay. And how reliable is that? Have you have any idea? So YouTube.
so I don't I think we did initially we did some we looked into it, but I think it was not very useful. That's why we didn't proceed into it. But I think we can take a look and see again and evaluate whether it is
Okay.
useful or not.
Okay. Fine.
Yeah, just one thing. So even if we have that annotated data, we still need to align it, right? And and the quality of the transcription which we saw, like sometimes even the language was incorrect.
Okay. Okay.
Yeah.
Right.
So it needs a lot of automation. If you want to do that at scale.
Okay. Then how was the transcriptions generated? Sorry if I'm repeating the question here.
Yeah. So we use like commercial text to speech to text engines to generate the transcription.
Okay.
So to automate the process, the thing is, like, most of our data we need for training is unlabeled data because of the self-supervised learning approach.
Correct. Pre-training, right? Yeah. Correct.
Right. Okay, so I'll go ahead and we'll discuss more about WED. So WED basically we are using for breaking our large audio, the big audio, into smaller chunks. So it basically just checks the voice activity and breaks the audio based on that. So it actually applies some classification rule to see if the voice is actually there or not, and that is already a pre-trained classifier that this utility is using, which we are using right now. So that utility is basically this utility. This is WebRTCT. It's from Google, right? It internally uses WebRTCT, which is Google developed, and as I said, it actually internally uses the classifier, which is already pre-trained, and it's already there as a part of the utility, which we are using. So if you see is speech method, so that's where it is calling this WebRTC web.process, which is nothing but internally it is trying to classify it as a voice or not voice, basically.
If
So,
data
yeah.
has a lot of noise, then how we are classifying?
Yeah, so that is the problem. So what we basically when the data is having a lot of noise, it doesn't break, right? It doesn't break the audio well. That's where the problem is. So what we do, we normally have a check in our system. If data is not splitted properly beyond 15 seconds, we reject that. So that's how we are filtering that data. We are not forcefully, or we are not having any, we are not trying to split the data which is having noise. That's the gist, basically. We are just keeping it as it is and disregarding, removing it from our data set if it is beyond a threshold.
That is manually or automatically, sir?
It's all automated. Nothing is manual. All automated.
So does it mean that you check if a sample has too many noises, then you reject it? But if
yeah. So basically, what we do, we first break that. Okay, if it is broken, let's say into 2 seconds, 5 seconds, 10 seconds, it will be broken to 15 seconds of chunks. It can be in 30 seconds or 1 minute as well if the it was not able to break, right? So what we do, we keep only 15 seconds, up to 15 seconds duration data. And then we also perform some quality checks using SNR. Basically, SNR is the signal to noise ratio, which gives you idea about how the signal is, basically how much is the signal, how much is the noise in my audio. So based on that, we again further reject the audio. Yeah.
Just like, since this is a statistical model and a huge amount of data will be used for training, don't you think like it's a good idea to involve noisy data as well, like while we train the models? What is your take on that? Yeah.
Correct. I mean, for model training, we definitely don't need very clean data. I mean, that's why we are keeping a threshold 20, right? So 20 to 100 data we keep. Like 20 means it is still having some noise, right? It's not like we are removing all the noisy data.
Okay.
We are also keeping, but
You
it's beyond
mean
that.
20 to 30 decibels is a safe enough data to consider?
20 to 100.
Which SNR is it? 20 to 100.
20 to 100.
SNR is it?
SNR, correct.
Signal to noise ratio.
SNR value, yeah. Okay, so we are using VADA SNR for it. I mean, that is the Git repository for it. And it actually is kind of it's automated and it's embedded in our pipeline. So we don't do it manually as well. So it's all automated. Okay, so next thing basically is the sampling rate of the audio. So sampling rate of the audio you can think of is a kind of a frame rate, right? It's basically how many data points are covered in one basically cycle, right? So that actually is the sampling rate. So as you can think, right, it's an analog to digital conversion, right? So when it's converted, how many data points are captured digitally, right? So that is what is the sampling rate, and it also is very crucial basically, since for model training we keep the sampling rate as 16 kilohertz only, 16,000 hertz. If we get the data from like 44K or 40K, that we convert, that we downsample basically from 40K to 16K automatically in the pipeline. So you can see in the picture, right? If the sample rate is low, it is capturing lesser data points, right? And if it is high, it is capturing more data points within that particular signal, right? The other thing is sampling. To calculate the sampling rate, we can use the utility which is SOX utility, and I can show you some basically I can run this command locally on my machine, and I think you are able to see that, right? So if I run it, I'll get the 16K, right? 16K I'm getting for this file.
Rajat, is there a way to increase this size? Like, can you
let me see that.
Yeah.
Is it fine? No?
Yeah, it's fine, Rajat.
Okay. So yeah, basically that tool is we can use locally on our machine and see like bit rate. I can see the number of channels and all these things. All the stats it provides basically. It's a good utility. Sampling rate, duration I can check, number of bits, bit rate as well. If I want to see bit rate.
Yeah, Rajat, I want to ask one question.
Yeah, please.
Yeah, so have you studied that how it is affecting by increasing or decreasing the sample rate, then how it is affecting the accuracy?
Yeah. So I think we tried with different sampling rates earlier, and I think it is recommended in the paper as well, in the Web2 paper, that it has to be 16K hertz. And for model training, since it is like for humans, it's 8 hertz, right? The frequency, and basically the double of that is because it's a two-way wave. So that is why I think it's basically 16K that is required for model training.
Yeah, so just I want to know that suppose I increasing the sample rate, so what happening, and by decreasing the sample rate, what happening with the accuracy? It is increasing or decreasing?
Yeah. So Anirudh, can you share your experimental results that you did?
So we haven't studied that extensively, sir. We haven't studied that extensively. So our requirement was to basically downsample everything to 16A sample rate, because that's the usual standard in the industry for speech-to-text systems. And it takes lesser storage size and all those things. The model training times are also less if the sample rate is less. So we didn't experiment that.
I mean, for sample rate, basically,
thank you.
larger the sample rate is basically more information, right? And more bits involved. So it needs more computation, and for vocal part, basically 16K is fine basically to represent the human voice. So that is
So that's why I was asking that suppose we, yes, sir, Surikant.
Just what happens with respect to this sampling rate is that, once upon a time, researcher used to consider 8 kilohertz because that is telephonic sampling frequency.
Right, sir, right.
Then maximum frequency content used to be up to 3, that is captured will be up to 4 kilohertz, that half of the maximum this one. But as speech is concerned, maximum frequency content of the sounds can go up to 7 kilohertz or 7.5. Therefore 16 kilohertz is standardized.
Yes, sir.
Yes, that is the reason why people stabilized at 16. For example, if somebody goes to 24 kilohertz, performance may not increase. Maybe some small amount, but not too much. That is the reason we stick that to 16 kilohertz. Yeah, thank you.
Thank you.
I want to add one more point. Like the variation with respect to low frequency is very distinguishable. Variation with respect to high frequency indistinguishable. So they have limited to 16K. That is appropriate. Like the variation in the upper spectrum, that is above 2 kilohertz, we cannot distinguish clearly. At below 2 kilohertz, we can distinguish very easily. Like that is the one point. Just have
Yeah, that is. Yes, sir.
Yeah, it is up to 4 kilohertz or 7 kilohertz. This according to the speech generation, it will be maximum frequency content till 4 kilohertz, no?
No. So for example, fricative, if you say you see in the spectrogram, it will go up to 7.5, 7.9 of again.
Okay. That means voice sounds we are telling that will go maximum 4.
Yes, most of the time, sound like maximum frequency content will be less than 4, but in few cases they will be up to 7.5. That's why, irrespective of what this one, we stick down to 16.
Yeah, so that may be the reason we are going for 16K. If you are analyzing audio signal instead of voice means speech signal, then maybe you can go for higher sampling frequency.
For example,
music signal or something. But
yes.
Voice, if it's speech signal, then 16 kilohertz will be fine.
Yes. Correct.
Thanks.
Cool. So let's move quickly forward. I think the other attribute is sample depth, right? So since sample rate is around how many data points are captured within a particular wave, basically it's more around how many bits are used to represent this basically wave. Like it is more vertical, and it's, as you can see here, in 8 bits, like in 16 bits, it is like split into 2 parts, and 8 bits are representing this first wave. But here in the later part of this, you can see it is representing 12 bits basically to represent the same wave. So you can see it's more continuous, right? It's more continuous to represent the continuity of the analog signal in the form of discrete bits. So that is the bit sample depth, and more it is, better is the representation of the curve basically using the same. Again, it would require more information or more data to be there to represent the wave. So we need to keep that into a certain threshold or certain specified number only. The next part is the bit rate, which is nothing but a product of both sample rate as well as your bit depth. And you can see the sample rate is bits per sample, and the bit depth is samples per second. Sorry, it's other way around, I think. And you do the product, then you get the bits per second. So basically, it's a kind of a single value for that is combining both sampling rate and sampling depth, sample depth. Cool. Any other thing you want to add, Anirudh, apart from this? Any other point? Or
no, Rajat, I think you covered most of the points.
Okay, cool. Yeah. So, shall we move to the hands-on? I mean, The reason I am talking about hands-on is if we can start the infra setup right now, all the prerequisites, if we can do right now, then in the next session that we'll have afterwards today, basically, then we'll be ready with something already there and set up that would expedite our whole process, right? So yeah, I'll tell you about the infra setup a little bit. Before that, I'll go with the architecture of our data pipeline, basically. So I've covered this data acquisition, data collection pipeline, right? That I think in theory, at least I've covered this. So let me cover a little bit about our intelligent data pipeline architecture. Let me make it bigger. I think it is visible. So you can see here. So we are using Kubernetes cluster where all our workloads will be running. The reason we are using Kubernetes is for the massive nature of the data. We want to run in parallel a lot of data so that we can bring it down the time it would take to process the data. So that is where the Kubernetes cluster is. We have Airflow, which is defining what needs to be done as a workflow DAG. So DAG is nothing but directed acyclic graph, which tells you what workflows or what jobs needs to be executed one after the other, and it's kind of orchestration tool. So here you can see we are doing processing, we are doing analysis, balancing, transcription, and then validation. So all this is done via Airflow. So that is the execution part, that is our execution engine, and our catalog resides in our PostgreSDB. So that is a RD relational database, which we can fire the SQL queries and see how our data looks like, right? It's kind of a view of our data set. Since it is audio, it is very important to keep that view in some data store. And then we have a cloud storage where we are actually keeping our audio, right? So I can quickly show you the code, all these components on cloud very quickly, so that it's easier for us once we come back for the hands-on. So this is Composer. So in Composer, you can see you can go inside the Composer and you can see the number of nodes there. It's a little slow. Okay. So here you can see the node is 3, right? 3 nodes are running, which are of type DB and one standard, like 2 CPU and 7.5 GB memory. Oh, that is a SQL machine. The machine type is actually N2 standard 4, and it is running in this region. So this is the Composer detail, and we can go a little bit more further in the later part. I am just touching it down, and yeah, so I can quickly open the DAGs as well, just to show you how the DAGs looks like. So this is how the DAGs look like.
Rajat, people are asking to actually increase the font size. It's hardly visible.
Oh, okay.
If you can just zoom in a bit.
Okay, can I permanently do that? Just a minute. Is it visible now? I think it is.
Yeah, it is visible.
Yeah, it is visible. Okay, so this is how the DAGs look like. So if I click on this DAG, basically you can see, if I go into the graph view, you can see like this Kannada first node, basically it splits that further into 2. So which means essentially it is processing 2 MP4 files in parallel. And then we are doing the data cataloging.
What do you mean by split into 2 files, Rajat? Is it time series or?
Yeah, so what this is having 5 files. Okay. This is just give me a moment. I'll show you how it looks like on the bucket, basically. So this is our bucket, and if you go inside, So here you can see like there are 3 files there, right? MP4
Yeah,
files with
there are
along
3
with the CSV.
MP4
These are 3 already downloaded that I downloaded yesterday. Okay, we can do this again, but these are the files that we want to process. It's a big file, right? And it's a one source, Canada new. So it's, by splitting, what I mean is splitting into multiple DAGs basically, so that we can process in parallel all of these files.
Okay.
Right. Yeah. So yeah, I mean, I just wanted to touch upon this. We will cover it more in more detail. Yeah, all these things we'll cover just after this call. For prerequisite, I think I would suggest everyone to download and install all these things. I think I'm just sending in the chat. Please install all these things if not done already. Whatever you've done already is fine, but all these will be handy for you. I mean, these are on top of what you learned already in the prerequisite sessions, right? So
You mean to say on the Google Cloud instances, right?
No, on your local machine. On your local machine.
Local machine. Okay.
Correct. Yeah. So that I think we can go ahead and. So yeah, I mean, I have shown you that the documentation for it. So documentation is this one. So we'll start with data collection pipeline. I'll just ping you that as well. So this will really start, and then we'll go further to this pipeline. So these 2 pipelines we'll cover today. Partially, the second one partially we'll cover today. And yeah. So I'll briefly touch upon the infra setup part. I'll not do it, or maybe I'll trigger it as well if you want. Then we can, because it will take some time, right? So we can utilize the time, and once we get back, I think our infra will be ready. So do you want to do that now, or is it? Do we have time for this session, or how much time is left for this session?
Rajat, give me 1 or 2 minutes. I'll let you know. I'll just coordinate with people and let you know. Yeah.
All right.
Yeah.
Rajat, we have a question from Mahesh. Yeah.
Okay, just give me a moment. I'm just checking.
Mahesh, you can go ahead.
Till 11:30. Yeah, Mahesh, please go ahead. Hello. Hello. Can you hear me, Sojo? Hello.
Yeah. Mahesh, you want to ask something? Mahesh Chandra, Professor Mahesh Chandra? I don't know. Maybe mistakenly.
Okay, no issues.
Okay, no issue.
I think so. Yeah, we have 30 minutes, right? Do you want to utilize this 30 minutes for initial infra setup?
Yeah, I think we can go with that, Rajat. I think 11:30.
All right. Okay. Sure. Cool. So as you saw in our architecture, that we have multiple components, right? I mean, and enabling them and provisioning them on the infra requires some kind of a. I mean, if we manually do all this setup, it's very hectic. I mean, it's going to take a lot of time, and there can be errors as well. So what we have done is we have defined it in our basically in the code, right? So this is the repository for this. I'll send you the repository name as well, just quickly opening that. Yeah, so this is the repository. So this is our infra repository.
I just spoke to the team. So you can engage till 11:15 or so. We can give a break of 10-15 minutes.
No
and
issues,
the team would start with the Kaldi aspect of it in the Google Cloud instance. Yeah.
All right. Okay, I'll just take few minutes basically just to touch upon the infra. So yeah, I think on my screen, you see this project is XStep Deep Speech Infra, right? This is the project name, and all the code, all the infra that we have is defined as a part of the code only. So we don't manually create the infra going to the console in the browser. We have defined everything as a part of our code here. So you can see it has multiple components like GCP bucket. We have composer. We have service accounts which are used to as a account for the machines basically. So for machines, we in Google there are service accounts specifically for non-human entities basically. Then we have SQL database basically. All these major 4 components we are spinning up and provisioning from the code itself. So okay, let me, I'll go through with the variables first. So in the variable, you provide the project. So project is your project which you see in the Google console. So like this is ASIR IITDH. Other project name is, I think, hyphen some ID, right? If I'm not wrong. Let me go to that. Yeah, so this is the ID. So if I copy it here from here, so what it means is whatever I'm applying against this project. What would be the name of the composer, which I have written XStep composer, GCP composer, the path of the GCP composer, which is this path. What would be the name of the bucket? So it would be group 1 hyphen data. What would be the database version, right? What would be the name of the database instance? In what region you want to spin up? What would be the name of the database? So like group 1 and group 2, I think we can remove this group 1 and group 2 things here. Service account, as I said, it also creates service account automatically. And what would be my type of the SQL instance? 2 cores with, I think, 7 GB memory. SQL disk basically 20 GB SQL disk I'm attaching, because right now we are just doing the workshop. We can increase it to 100 if you want to productionize and use in the production manner. So let me quickly do one thing. It's taking a hell lot of time. Yeah. So first thing is I need to ensure that I am pointing to the right account. So what I'll do again, I think I can do init again basically, and yeah. So I can do three basically. I'll create a new configuration and we'll switch to that as well. Yeah. So I'll log in with SHR only. Yeah. So here I'll see all the possible projects that are associated with my email ID. So I can see this one. This is the for group 2. For group 1, I already did the setup yesterday. So it's already there. I'm just giving you how we can set up the whole infra on for the group 2 basically cloud group account. So I'll use 2. So I think this is configured now. Okay, so if I do Terraform plan, basically in the Terraform, you can also see what can be applied. So in the Terraform plan, you will get the understanding of what will be the change in my infra once I apply all this. So it is checking the state. Basically, it keeps the state as well. So I think what I should do is I should I think the problem is I ran it for other accounts. So I'll just remove this, or I'll just take a backup of this TF state file because that was for other account. I'll do Terraform init. So Terraform init will basically initialize it with the initial state basically. Right. So if I do Terraform plan now, I think it should give me the right. Okay, I think somehow I'm not switched over to the account. Seems like. Okay, I'll just. Oh, I think it's already showing this, right? Actually, this Terraform state is causing the problem. Okay. I think I need to remove it from here as well. The reason is we are using test. So there is a concept of workspace in Terraform. So workspace means it provides isolation to work in a certain environment. I am basically again making the changes here just for. I'm selecting the test workspace. Let's do one more time. Right. Okay. Let's try the plan again. Let's hope this should work. This should work. Okay, I just need to check whether it is pointing to the right project or not. Seems like it is, because now you can see it is trying to connect, and it's like you can see this plus sign means it is trying to add these things, these components basically, which means it is pointing to the right one. Yeah, the project is basically this one, right? So what it will do, it will basically, let me make it bigger. So what it will do, it will add all these things to my cloud infra. So it will create bucket, okay. It will create composer. It will create the service accounts. For Circle CI, I'll talk about what Circle CI is later basically. And it will create the Cloud SQL database. So yeah, whatever is required, it will do that basically automatically. So shall I apply basically right now so that it gets created? Meanwhile, we come back.
Rajat, participants will also edit the code and they run. Is it in the
so they can basically what we can do is, do they have their own GCP account, because 300 credits is there, right? $300 credits. So can we use individual accounts, because they will learn how to do the setup. Because if I do setup on the second account, they will not be able to do again,
yeah,
right?
that's the reason. So or else, like, we can ask them to do, like, say, in the practical hands-on session. So that is one thing. And I don't know if all of them have created the accounts. I mean, even
I think most of them have created, sir.
No, in a sense, their own free account, Jagbandhu.
No. In our account, they are
in
using.
our account they've created. So unless they, yeah, okay.
So I am talking about the personal account, but personal account means,
yeah, this is personal account. I mean, their own account, Jagbandhu. Yeah.
Yes.
No, I don't
Correct.
think they have created. Maybe they are using our method.
Maybe what we can do is we can pass on the slides, right, to them, and if they have credit cards with them, they can create accounts on their own, and that will be useful for, say, such things. I mean, so we can utilize those.
Right. I think correct. I think we should do it, because anyways everybody can use at least 300 account. At least in a group, if even one person can do it,
yeah,
it would
even
still
if
work.
one has in a group, they can share the knowledge, right, Jagbandhu?
Yeah.
So slides, okay, Windows has sent clear step-by-step process. If we have similar thing on the Linux, that should also be fine. Yeah. So maybe we'll pass on the slides.
Sure, sir. Sure. So right now I'm applying this on our account too, basically, which is for this one. I'm applying this Terraform apply. It will create all the components. So at least meanwhile we'll come back, we'll have all the infra ready. So I'm just doing it.
Rajat, if we have given them service account permission, they can't use that.
Which, sorry, sir, what do you mean by that?
Yeah, we have given this when we add their mail ID. No, we have given that permission about service account.
The problem is this has to be done only once for one account, right? The whole project.
Okay.
All people cannot do, cannot
All
override this.
different
Once I do it,
yeah.
we should not change it, right? It's one time.
Okay. Then they can't.
So I'm just searching this if by mistake, if it is. Let me just see what changes I have made. So here also I need to change. So I'm just checking at what places we need to make this change for project, basically. I think we can drive this as well from the only one variable here. We should not copy it at two places, but yeah, for now it is at two places, but we have to, yeah, I think we are done. So I'll just quit to it again so that, so I changed the project at two places. One is in the patch.sh file and one is in the variables.sh file. So this patch.sh is nothing, but it actually adds more things to the composer environment automatically. And it also creates kubectl secrets on our local machine. So it's all script in script, so we don't need to do anything manual. There are multiple things that we need to do after the composer is started. So that script actually does all that automatically. Okay, now I think I can
Also,
press.
we can make a short document to edit the script, right? Yeah, if we can keep that in a repository, that's useful
Correct.
for others.
I think actually it's already there in our documentation, but actually I know these things. That's why I am not following. I mean, yeah, we will share that documentation.
Yeah.
Okay. Thank you, sir. So, I mean, and in this, if you'll see, basically we have changed these things. So only file which is changed, which needs change is this variables file. Whatever names you want to give to all the services, that it can be derived from here. So it is trying to build this. It is creating a lot of things. So let's see if it has created the bucket or not. I think bucket was the initial one. So let's see if bucket is there or not. Okay, so this I think is account 1 if I'm not wrong. Let's switch to the other account. Oh, I don't see anything here. I think it's still creating, it seems like.
It will take some time, Rajat.
So I think I've given name of the bucket as group 1 only. Oh, sorry. I think I should have given group 2 actually, but I think it's fine. Cool. I think this will go on. I mean, it will take 30 minutes to set up everything automatically. So once we come back, hopefully we'll have everything in place. So Deepak sir, can do we want to continue, or as you said, by 11:15 people will?
Yeah. So 11:30, I think they'll start with that Kaldi thing. Let them finish that, and post that lunch, like we can have this yours hands on. Yeah.
Sure. I think we can give 10 minutes to the participant just for the break. Is it fine?
Correct. So now if we can break, and maybe if they can come by 11:30, they'll start with that Kaldi thing. Let them finish that Kaldi. Then post lunch, like we'll start with this thing.
Sure.
Is
Sir,
that
sure.
fine?
Yeah, I think it is fine. I mean, it won't take much time once this infra is ready, so it will be very quick.
Yeah, fine. Okay. Okay, Rajat. Yeah.
Right.
So we shall have break to all participants. Like, shall we assemble at 11:30, Jagbandhu?
Yeah, fine, sir.
Yes, sir. We can assemble it.
Yeah. So just a quick check. Are we moving in the right direction? Any quick thing that we want to course correct in this whole?
Yeah. So I think we should get feedback from participants because if they tell what is their problem, accordingly we can fine tune our. Participants, you need to come up with whatever.
Excuse me, sir.
Please.
So, is it possible to kindly share the list of commands which is needs to install prior to moving ahead? Okay, so that's maybe fine. I think.
Rajat has shared that in the chat box, if I'm correct.
Now, these are the commands only we need to run.
Yeah. So basically, we have all the commands there in the documentation. So idea is, as we are running the commands, you will get to know about the commands. Because if I give you all the commands, it's already there in the documentation. But that would defeat the purpose of having the workshop, right? I mean, we could have shared that already. So the idea is you will see that in action, basically, whatever commands we are running, and then you can go back to the documentation as well and basically correlate to that. And I think the idea is if you can spin up your own GCP account, you can do that from ground up and do it by yourself, everything. So,
Okay. So, this one, Jagbandhu, shall we share them the document how to create a GCP account on their own, so that like at least people who have a credit card, they can create their own accounts.
Yeah, we can do that. We can share a document such that they can create their Google Cloud account.
Yeah. Share the document, and maybe once you can explain them at 11:30 with those slides. I mean, how do they create an account and how would they create?
Will that slide is available with us? I don't think.
Instance I've created, and even Google Cloud account I've sent you, right? There's no difference between Windows and Linux.
Yeah, cloud account we can use the same way.
Yeah. So even instance, only difference being the SDK installation, which I think they've dealt yesterday.
Already they have dealt yesterday.
So Windows, like how do they install SDK? I've shared the slides.
Yeah.
I think that completes the loop. If we can share those.
Okay, we'll do that.
Slides, Okay, so we'll meet at 11:30 then. Thank you, Rajat. Thank you.
Sure, thanks.